7.3 has us working with factoring using what's referred to as the AC method. So it's kind of one of our main essential methods that we use for factoring and kind of a go-to if we aren't sure what to use when we're given a polynomial. Now the main instances we are going to be using this are when we have a polynomial written in the form of ax squared plus bx plus c. A, b, and c in this instance are integers, sometimes they're fractions, sometimes they're decimals, but more often than not for what we're going to be seeing in this class, we're going to be seeing them as integer numbers. They could be positives, they could be negatives, either of those, but we're going to have integers for the most part with these. Now the nice part about the AC method is it's a big upgrade from what's referred to as the trial and error method, which is basically just the equivalent of saying, hey, guess at some numbers, which we're not going to do. We're going to be procedural with it and actually have a process that we follow. So listed below here we have the process that I recommend using with this. So I'm going to go ahead and highlight these methods and parts that I would recommend we take note of. And if necessary, I would pause the video here for a couple seconds to write these down for yourselves. We're going to go through these shortly, but I think they're worth having notes in your own record so you can add and modify those accordingly. Now our first step with the AC method, and this is something you want to do with any and all polynomials that you are factoring, whether it be the AC method or something else. We want to find and factor out the greatest common factor of all terms in the given expression if it's possible. Sometimes you can do this. Sometimes we have a greatest common factor and sometimes we don't. It all depends on the problem that we've been given, but if you can, you want to make sure you do this. We're going to see later on with a couple of these examples that if you do actually do this process, as part of the process, it's going to make numbers much easier to work with later on. And that's going to become pretty apparent here with some of our examples we're going to see. Next, we need to identify what are the A, B, and C values in the resulting first, kind of our first layer of factored expression. So we're factoring some stuff out, we're going to get something left over. Okay, what's the A, B, and C value? I think it's very useful to write that down for yourself somewhere nearby, and we'll go through some examples with that. Once we have the A, B, and C values, we need to find what is the product of AC, meaning I'm going to take the A value and I'm going to multiply that with the C value. Make sure when you are identifying values for A, B, and C, you are including both the number and the sign that is in front of it as well. It's very important that we have that listed out here. So now that we have the product of A times C written out for ourselves, we now need to determine and find two numbers listed as m and n, but really just we're finding two numbers that multiply to equal the AC value that we just found here and add together to equal the B value or the middle value that we have from our original expression. Now we're going to go through a method that I think it's reliable and that it will give you all the potential values that you could be using to fulfill both of these requirements. There are a lot of ways you could do this step and write it out and organize it for yourself, but I'm going to try and demonstrate one that I think is very mechanical and again doesn't require a whole lot of guesswork with that. So if we are able to find two values that multiply to be AC and add together to be our B value, great. We are then going to split the middle term being this bx we have here, using those two m and n values, the two numbers that we found in step 3. So this bx, this middle term, is going to split apart into first value, our second value that we have here. When we're doing this, we need to make sure that we're keeping the signs of our two m and n values the same. So if m is a positive and n is a negative, those need to carry on down here. And again, we'll see an example of this here soon. So once I'm able to split that middle term, that bx value, I'm now going to have something that's going to have 4 terms in it. This bx became 2 values here, so I would have ax squared plus mx plus nx plus c. So I have 4 terms written here. And the only method that we have to go through and factor that any further is factoring by grouping, what we covered in the 7.1 material. So we go through that process of what we've been given, and then we're going to end up getting a final answer from there. If you would like, step 6 is technically optional, but I think it's nice to do every now and then just to make sure that we have the correct answer. We can check our final answer that we have by multiplying everything together. If we multiply everything together and we get what we started with at the very beginning of the problem, yay, we fully factored this thing correctly and we are good to go. If something ends up going wrong and we don't get what we started with, could be that we multiplied something together incorrectly, could be that we combined like terms together incorrectly, or maybe we actually did something wrong in our factoring process incorrectly. So we're going to go back and check on those as necessary. A big portion of this is, or be able to find that, I should say, is going to depend on if you are or aren't showing your work. That could save you the potential of having to go back through and do this entire process all over again. So I think showing steps as we go through this is very, very helpful, and again, we're going to see some examples of that here shortly. A couple things, last parts I want to mention down here. We can still have prime polynomials showing up as we go through this process. That could mean I can't factor anything out from our first step. I couldn't find any two numbers that multiply to be AC and add together to be B, and then I just can't do anything with the original thing that I've been given. It can't be factored, and that's not a reflection on you're missing something, there's some trick somewhere else with it. It's a prime polynomial. I can't do anything with it. The one hint I will give you, and I think this is also worth writing down, so I'm going to grab the highlighter here. As a good rule of thumb, if you are able to find two values, m and n, in step 3, again remember step 3 is finding and meeting both of these requirements. If you can find two values in step 3, then the polynomial can be factored out even further from there. So we can go all the way down and finish fully factoring this thing out if that happens, if we find these two values here. So with that, if you need to, I would pause the video here, write these down as necessary, or write any additional notes down as necessary, and we're going to jump over and do a couple examples. Our first example that we're going to take a look at is 8y squared plus 16y plus 6. Now, following our process that we have, the first step says to factor the greatest common factor of all terms in the given expression if possible. So what I'm going to do is I'm going to look at each of these terms that I have here. I'm seeing, is there something I can factor out of all of them? Turns out in this case there is. I can factor out a 2 from all of them. So I'm going to make a note off the side that there is a greatest common factor of 2 amongst these. And I'm going to factor a 2 out, just like we've done in our previous sections. So if I'm factoring a 2 out, I can think of that as basically saying I'm taking each individual term that I have been given here, and I'm effectively dividing it by this greatest common factor. So 8y squared, that's going to become 4y squared. Plus 16y is going to become 8y. And this 3 at the very end, or this 6 at the very end, spoiler alert there, is going to become a 3. So I now have my first step done. The greatest common factor has been pulled out. It's sitting out front here. We cannot drop or get rid of that greatest common factor of 2, but now it's just going to be staying along with the rest of the problem, going along for the ride. It's doing nothing to affect anything else we do, so we just need to leave it there. So when we see this, you're going to see me write this out in future steps as we're working through this problem. It's doing nothing. This was just the first step in the overall process, and that's all it does. So we're done there. Now looking at step 2, it's telling us identify the A, B, and C values in the resulting expression. Again, for me, I think it's very, very helpful to write out the A, B, and C values somewhere nearby. So I'm just going to do this right next to the expression that I'm working with. So what's my A, B, and C values? Remember, when we are identifying these, we need to determine both the number and the sign. So I'm having my A value of 4, B value of positive 8, and a C value of positive 3. So I'm going to write those out right off to the side here. A, B, and C. Perfect. Next part of step 2 says to find the product of AC. That means I'm going to take A, multiply it by C. The numbers that I have, that's going to be 4 times 3. It's going to be 12. Okay. Product of AC is 12. Perfect. Step 2, done. Now step 3 in our process. Find two numbers, m and n, that multiply to equal the AC value and add together to equal the B value. Now there's a couple ways you can go through this. You can sit there and think about it in your head and go, well, it could be this number, it could be that number, it could be all those different things. I want to show you a way you might be able to organize this that I think takes a lot of the guesswork out of that process, especially when these numbers get big, gross, and terrible, which we'll see here shortly in our second example. So if I want to find numbers that multiply to equal AC, meaning 12 here, why don't I start with just listing off all of the numbers that multiply together to give me 12? I find it very effective to list what's referred to as the factor pairs of a number. And factor pairs are just what are two numbers that multiply to equal 12. Now we're going to list these off in a very organized, very systematic way because there's a little bit of a trick that shows up that we're going to be using in future examples. So I'm going to start with listing 1 times 12. If you're going to use this method, I always recommend starting off with 1 times the number. You can always use it, and actually it shows up a fairly common amount of the time that first pair of numbers are ones that we're going to be using. So we start with 1 times 12. Our next number, well, does 2 go into 12? Yes, it does. 2 times 6. Does 3 go into 12? Yes. 4 times, so I got 3 times 4. Does 4 go into 12? Well, I already have a 4 listed right here, so I'm now done. I now have all of the numbers that multiply together to give me my AC value, 12 right here. So great, now I just need to determine which of these numbers when added together is going to result in giving me my B value of 8. So if we look through these, we think, okay, well, 1 times 12, that doesn't work. 1 plus 12, that doesn't work. 2 plus 6, well, that does. 3 plus 4, well, that doesn't. So it's going to end up being 2 and 4, or 2 and 6 here, I should say. So now we've just completed step 3. Find two numbers that multiply to AC and add together to B. So perfect, we have that there. Step 4 says to split the middle term using m and n. So all I'm doing here is I'm going to be doing a rewriting step. I'm not really changing a whole lot, or I'm not doing a whole lot of math, I'm just rewriting what I was originally given. So we see here our original B value, or B term, is now being split apart into the values that we have here. The order in which you write these really doesn't matter, so if you wanted to write the 2 coming after or the 6 coming before, that's fine. As long as you have the numbers and their signs the same, you're good to go. So there's step 4, done. Now looking at step 5, step 5 says to factor the resulting expression by grouping. So I am only going to be looking at what is listed inside of this set of parentheses, and I'm going to factor that. Now factoring by grouping says I am only looking at the first 2 terms and the last 2 terms at a given time. So I'm going to rewrite this a little bit to make that a bit easier for myself to track what I'm doing. So I find it helpful when I'm doing factoring by grouping to kind of separate these out and underline. There's my first group, and there's my second group, so I'm not getting anything mixed up. Factoring by grouping says take the greatest common factor of the first 2 terms. So between 4y squared and 2y, what's the greatest common factor? That's going to be 2y. Factor out of 2y. What's left over? I have 2y plus 1. Now looking at the last two terms, 6y and the 3. What's the greatest common factor between those? The largest thing I can factor out is a positive 3. Okay? So I'm factoring out a positive 3. What's left over? 2y plus 1. It should be noted, again, this 2 out front is carrying down like we did from the very beginning. It's not affecting anything, it's just along for the ride. Everything that I'm doing is now inside of this set of parentheses. So if you're noticing that in our current step, well, I've got parentheses inside of parentheses and all of that happen. Yeah, because we're working with what is inside here. So I'm not done with factoring by grouping. I can do a little bit more, and I'm noticing these both have a common factor of 2y plus 1. I can factor that out. And then what's left over after I do that? It's just this 2y plus 3. The 2y plus 1 comes out front for both of these. And then what's left over? Just the 2y and the plus 3. And that's what follows down right into here. So we have our final fully factored answer of 2 times 2y plus 1 times 2y plus 3. And there we have our final answer. Our second example that we have here is 6n squared plus 19n minus 20. So following the process that we have, we wrote down before, again, I'm looking to see, is there a greatest common factor I can bring out from all of these terms here? Turns out there isn't. 19 is a prime number, so I can't factor anything out from there. That's fine. We always check for it. Sometimes we can, sometimes we can't factor something out, just how the numbers are. That's fine. So our second step, we're identifying our A, B, and C values. Remember that when you are identifying these three values, we need to make sure we are keeping the number and the sign listed there. So my A value is 6, my B value is positive 19, and my C value is negative 20. I'm getting ahead of myself there a little bit. So we have those listed there. And now I need to find the product of AC, so I'm listing that out here for myself. A times C, the same as saying 6 times negative 20. And we're going to get negative 120 as our answer there. Now, as mentioned previously, these numbers are going to get bigger, going to get larger. We're going to have a lot more that we're going to have to keep track of. This is where, for me personally, I think it's very helpful to write out the steps for what we're about to do in step 3. Otherwise, you're keeping track of a whole bunch of numbers in your head, and I don't know about you, but I always get mixed up and lost and forget stuff along the way. Also going to move these here a little bit because we're going to need a bit more space later on, so we'll just move those over there. So step 3 in our process says we need to find two numbers that multiply to be our AC value that we have right here and add together to give us our B value of 19. So again, as we did with our previous problem, I think listing the factor pairs of a number is the most, I'd say, consistent way of finding these, or potentially finding these. It takes a lot of guesswork out of it, a lot of memorization out of it, and it's super mechanical, not a lot of guesswork involved. So again, we're going to start with 1 times 120. We're then just counting up from there. We're going 2 times, I believe it's 60. Oops, let's make that a better 6. There we go. And then 3 times 40, and so on. We're going to list the rest of those out. Now, I'm going through, and I've calculated these. I'm going to write these out off to the side for myself. Or I've done these off to the side using a calculator. So if you need to use a calculator to help you check each of these, that's perfectly fine. I recommend doing that because when we get to big, large numbers like 120 or ones bigger than that, it's not always easy to be able to figure out and calculate all of those in your head. So the numbers I'm listing here, I'm calculating onto the side with the calculator. Just make sure you're counting up by 1 in the left-hand column, and then you're listing the larger numbers on the right side. So let's see, there, 5 and 24. Make this a bit clearer, multiplication. Dots here. We have 6 times 20, 8 and 15, 10 and 12. Oops, make that a better 10. There we go. And then 12, and okay, we already had that, so I'm going to end there. So now I've just listed off all of the numbers that multiply to give us 120. We have a little bit of an issue that's showing up here. I'm not looking for numbers that multiply to give me 120. I'm looking for numbers that multiply to give me negative 120. So that tells me that the signs of these two numbers, whichever ones in these columns, these signs have to be different. One of them has to be a positive number. One of them has to be a negative number. Well, which one is which? That's generally the question that shows up with this. And we look at this and might go, well, I don't know, but one has to be positive, one has to be negative. Okay? Well, if these things need to result in a negative number when they multiply, that tells me the signs need to be different. That's all that I can get out of that. So our C value, if our C value is a negative number, then that tells me that each of these columns that we have here need to be different signs. One is positive, one is negative. Well, which one's positive, which one's negative, that's going to come down to our B value. It's also dependent on you listing all of your small numbers in this left-hand column and large numbers in a right-hand column. If you follow that pattern, then this is a really nice trick you can use. Which column is positive, which one is negative? Well, if you organize it that way, the B value, being a positive number, positive 19, is always going to tell you the sign of the larger column. And we get that by saying, well, if I'm adding these two things together, should my result be positive or negative? Well, my result needs to be a positive, which means the larger numbers have to be the positive ones. It's the only way my result, when these things add together, is for them to be a positive answer, is if the large numbers are positive. So I'm looking through this and I'm seeing, okay, well, which one of these combination of numbers adds together to give me a positive 19 then? And that's going to be the negative 5 and the positive 24. I like listing the signs at the very bottom. You can list them off to the side for yourself or right next to the numbers. It's your call. This is just how I organize it. So now I have my two m and n values. So step 3 is done. Step 4 tells us we need to split the middle term using those two values that we found. So this 19n is going to split apart into the two values that we just found. My recommendation, list the negative number first, positive number second, in this ordering. So we have that there. Perfect. Split that apart. Now we need to factor this thing using the factoring by grouping method that we have. So again, I'm looking at my first two terms, I'm looking at my last two terms individually. But the first two terms, what's the greatest common factor between those? The only thing I can factor out is an n. What's left over? 6n minus 5. Best I can do. Looking at the last two terms, looking and seeing, well, what's the greatest common factor I can factor out of that? Looks like it's going to be 4, a positive 4. So I factor a positive 4 out. What's left over? I'm getting 6n minus 5. Now factoring by grouping again says I'm not done. I'm noticing that both of these things have a 6n minus 5 in them. So I can factor that out from both of those terms. So if I factor out, if I factor out a 6n minus 5, what's left over? Well, in the first term it was an n, second term it was a positive 4. So I have an n plus 4 left over. I can't factor that any further, so I'm good to go. I have my final answer. So this brings us to our last example that I want to go through with you, kind of a weirder looking one, but still something that shows up from time to time. So we're still going to follow the exact same process that we used previously, even though we've got something that's a bit weirder showing up. So I'm looking at this and saying, first and foremost, is there a greatest common factor between everything that I have been given? Turns out there is, and that greatest common factor is going to be 4. So I can factor a 4 out of both of these terms, and just like we did previously, that 4 is just along for the ride now. It's the 4 that we brought out front here. So it's just going to sit there. Can't drop it, can't get rid of it, just have to leave it there. And now I'm following the rest of the AC method. I'm identifying what is my A, B, and C value. Oops. There we go. A little bit of glitching showing up there. So, A value, it's going to be 4. Showing up right here. We're looking at this and saying, well, you might look at it and say, well, I don't have a B value. There's nothing that's been given to me there. And you are correct. Nothing has been explicitly written as the B value. You can also think of it as, and if you're thinking, well, I have nothing there, what's the mathematical equivalent of nothing? Well, that would be 0. And then the C value, which is just the constant at the very end, that's going to be this -9. Okay? Excellent. So now I have my A, B, and C values. I'm multiplying A times C, just like we've done in the past. I'm getting -36 out of this. I'm going to move this over a little bit. I always write this a little bit close in here, so move it over, give ourselves some space. So I have my product of A times C. Perfect. Step 2 is done. Moving on to step 3, I want to find two values that multiply to give me AC and add together to give me B. Now, admittedly, a B value being 0 is a little weird, a little out there. We can still do it. We're doing the exact same thing that we've done. Our process isn't changing. So I'm starting off, I'm listing 1 times 36, 2 times 18, and so on. So all I'm doing is just listing the factor pairs. Oops, it's not going to be 6, it's going to be 12. 4 times 9, 5, and then 6 times 6. Okay, cool. So now I'm looking to see, all right, well, what are two numbers when they add together equal to 0? Well, again, first and foremost, we need to keep track of and look at the signs of this thing. The AC value is negative, meaning one of these has to be positive, one of them has to be negative. Which one? I'm not entirely sure. Well, that's where we take a look at our B value here. Say, okay, well, hold on. Our B value is 0. 0 isn't positive or negative. It's its own weird kind of own thing. So that means I need two numbers that when they add together, they completely cancel each other out, and all that's left over is 0. Well, if we're looking at all of our possibilities that we have here, the only possibility of two things adding together and canceling each other out are going to be 6 and 6. One has to be positive, one has to be negative. Does it really matter which one? Not really. We know 6 and -6 are the only possibilities that we have. So now we're going through the rest of our process. Step 4 says to split the middle term into those two values that we found there. Again, I recommend listing the negative first if possible. So get to that there. And now, just like we've done in the past ones, I'm using factoring by grouping. I'm looking at the first two terms, I'm looking at the last two terms, and I'm finding the greatest common factor between those. So between the first two terms, a greatest common factor looks like it's going to be 2x. And then what's left over? We have 2x minus 3. Between the last two terms, what's a greatest common factor? Looks like it's going to be a positive 3. And what's left over? 2x minus 3. Make this 2 a little bit better here. Now again, doing one last step of factoring by grouping, I'm looking and noticing that they both have a 2x minus 3 showing up there. I can factor that out. So I have 2x minus 3 factored out. What's left over? This 2x and this plus 3. Oops. A little bit of glitching showing up here. Plus 3. There we go. And I can't factor this any further. So I'm good to go. I have my final answer. So there we have a couple examples of factoring using the AC method. Again, if you haven't, I would highly recommend that you take some time to write down the notes, or at least the highlighted portions of the notes that are listed here for yourself, so you can reference these on your own or modify them and write them out for yourself accordingly. The examples that we went through are listed right below here. We didn't go through example 3 because I want to give you something that you can work through on your own here with the answer provided here. Some practice. And if you do want some other additional practice problems, I do have them listed right down here. If you need to, I'd pause the video here and try some of these examples for yourself. I am going to scroll down here shortly and I'll show you the answers so you can reference those on your own. But if necessary, I'd pause the video here, give yourself some time to work through these either by yourself or, hey, maybe with a group if you're doing this with someone else. But give these a try. Pause the video here as necessary. And then I'm going to scroll down here and give you the answers. Then that's everything for the AC method. We have our answers listed here. Hopefully caught on to the group 3 problem 1 being a prime number, meaning we can go through the process exactly as it's been given to us. We can't factor anything else out. It happens, it shows up. Wanted to give you an example to give that a try there. But otherwise, this is our video on how to go through and factor polynomials using the AC method.